Okay, I'm now recording for the engineering principles class on December the 3rd. Prior to turning on the recording, we worked through some problems that I purposely left the recording off because I did not want to embarrass people. I did not want people to be afraid to talk up because they knew they were being recorded. So what we did was we reviewed some problems there. Now we're starting into a new problem. And let me just go ahead and clear this off so we start from scratch. Okay, we're assuming that we have a bridge like you see over here. And so this is the water down here, and we've got a truss bridge. And in order for this bridge to not fall down, anywhere where we analyze the forces, if we analyze all of the forces that are acting on any joint here, those forces had darn well better add up to be zero, because if they don't add up to be zero, that means this bridge is going to fall down. If they add up to zero, that means it's in equilibrium, and equilibrium is good if you're a civil engineer. Okay, so what I'm doing now is I'm focusing on one joint, and I'm going to suppose that we have a force coming in this way and a force going out that way and a force coming up this way. Now, if you're wondering now, Mr. Hendricks, how did you know what direction the forces were going? Well, we're going to talk about that next week. For right now, let's just take it on faith that these forces are what they are. Okay, so now, if this force here, let's just make up a number. Let's say this force here is 27,000 pounds. And this force right here, let's just make up a number. Let's assume that this force is 1,500 pounds. Or let's say 15,000 pounds. Let's make it be that. Okay. So now the question then becomes, what would this guy have to be in order for them to be in equilibrium? Remember, my goal here is I want all of the forces to equal zero. I want them to be in equilibrium. So what would this guy here have to be in order for that to be the case? Right? Well, what we can do is we can recognize that he is a funky force, and we don't like funky forces. We like nice even forces. And so then we say, okay, what do you do with funky forces? Well, you break them up into their components. Right. So this guy here is the horizontal component. This guy here is the vertical component. And so if this force here, we don't know what it is, so let's just call it F. Okay. And let's say this angle here, let's say we don't know what that is either, so let's call that angle theta. And hopefully you realize, you guys know that if you got two horizontal lines and you cut by a transversal, this angle here and that angle there are the same. In fact, we have a name for them. We call them alternate interior angles. Do you remember that from your math class? Okay, so that means this angle right here is also theta. Okay, so our job then is we need to figure out, oops, oh, I didn't mean to do that. Oh, I hate it. I accidentally erased them all. So give me a second to redraw that. Okay, so what can you guys remind me what the numbers were? What was their vertical force? Somebody help me out.
27,000.
27
27,000.
and then 15.
And then
Okay.
15,000 the other way.
15,000. Yeah.
All right, thanks. Okay, good. All right. And so now we've got this other force here, and we want it so that this other force will balance out the other two. Okay, we want sigma F to equal 0. Okay, so this guy, he's F, and if we replace him with his components here, so we're going to have that horizontal component, that vertical component. So we want these two vertical component, or these two components, to cancel each other out. Okay, so what would the horizontal component of this guy have to be in order for them to balance out? Well, what other horizontal forces do you see? I only see one other horizontal force.
It has to equal it,
Yeah,
but
it
to the opposite
has to
way.
equal and opposite, right? So the only way these forces are gonna balance out if the horizontal component of this guy is also 15,000. That's the only way that they're gonna balance out. Now, how about the vertical component? What is that gonna have to be in order to balance out? Well, let's look to see what other vertical components do we have in our picture. I'm seeing a vertical component here and a vertical component here, and that's all I see. So that means that they had darn well better balance each other out. Okay, so that means that this vertical component must be 27,000. That's the only way that everything can add up to be zero. Okay, so now I know what the horizontal and vertical, fix that. I know what the horizontal and vertical components of my force are. So now I can figure out what this force needs to be. Right? So this angle here is 90 degrees. So I can just use Pythagorean theorem, a squared plus b squared equals c squared. That will tell me what this force needs to be in order to balance out. So I'm going to do this 1500 squared plus 2700, or I'm sorry, 15,000 squared. Let me try that again. So 15,000 squared plus 27,000 squared. It gives me that. Now let me just take the square root of the thing that I just did. Okay, so in order for these forces to balance out, that guy there must be 30, not 20, 30. Okay, that guy there must be 30,886, which is more sig figs than I'm allowed, but let's not worry about it. And that, by the way, that's 0.89. Okay, all right. And so if I'm only allowed two sig figs, then I would say 31,000 pounds. That is what this force needs to be in order for them to balance out. But I also need to worry about the direction here, because if it's only going to work if that angle is the right angle. If I have this 31,000 pounds, but he's coming down like this, it's not going to work out. Or if he's coming over like this, it's not going to work out. The only way this guy is going to balance the other two is if he's 31,000 pounds, and also this angle here is the right angle. So how would I figure out what that angle needs to be? Well, hey, I've got everything I need. I know what the opposite side is. I know what the adjacent side is. And I also know what the hypotenuse is. So I could use any one of our three friends. I could use the sine, I could use the cosine, or I could use the tangent. Any one of them would work. Okay, so let's use the tangent. Okay, so I'm going to say tangent of theta equals the opposite, which is 27,000, divided by the adjacent, which is 15,000. Okay, but I don't want tangent theta, I want theta. So I'm going to take the inverse tangent of both sides. So I'll get the inverse tangent of 27,000 over 15,000, which, I can get rid of those zeros if I want. Okay, so if I do the inverse tangent of 27 divided by 15, or 27,000 divided by 15,000 if you want, it's going to be the same thing. So I get 61 degrees. Okay, 61 degrees. So 61 degrees, that has to be what this angle is. So the only way that I can get my bridge to stand up is if this force here is 31,000 pounds, and at the same time, this angle here has to be 61 degrees. Now I realize my degree there looks like a zero. Let me fix that so it's more like a degree. 61 degrees there. Is that better? Okay. So in your homework tonight, I'm going to give you a problem like that, where I'm going to say, okay, we got a couple forces here, and we need a third force that's going to balance out these other two forces. So your job then is to figure out, okay, what do you do it in order to make it so that all of the forces equal each other? Okay, so the way to do it is look at the vertical forces and make sure that they balance. And then separately, look at the horizontal forces and make sure that they balance. Okay, and then you'll be in good shape. Does that make sense, everybody? So can you type in the chat box yes or no? Yes means, yeah, okay, I think I got it. No means, no, we need to work on it a little bit more. Okay. All right. So let's see, we've got 30 minutes left in class. Okay, so I'm glad to see that you thought the review helped. That was good. All right, so we have 30 minutes left in class. What I'm going to do is I'm going to let you guys work on the quiz. If you want to say goodbye and sign off, I'm okay with that. If you would rather keep Zoom open and work on the quiz while I'm sitting here so that I can maybe help you if you think you need help, I'm willing to do that. Here, what I'll do is I'll turn off the recording so that you can ask questions if you want.